So error matrix, as we all have seen, right? What are the errors that we considered at the starting? Absolute and square, right? Right. Now, the first is we are going to see the error matrix, right? So error matrices. Okay. The first one, obviously, is going to be mean absolute error. Can someone tell me what it is? As the name suggests,
It
this
will
is
be
nothing
based
but
on
Average of
mean.
Absolute distance from that point, right?
mean
Mean
of
the absolute distance.
the
Mean of
absolute value of errors. Okay. Now, what was our error? Can someone tell me? Y minus y predicted. This was our actual error, yes or no?
Yes.
Yes, right.
Right. If we take the absolute means this, correct? And mean means first you do summation from 1 to n and then you divide by n. Correct?
yes.
yes.
Right.
You have to go reverse. Error, then take the absolute and then take the mean. So any confusion here? What is mean absolute error?
No.
No.
Okay. The next one is, we are going to see what is the difference and when we will take it by just a small example. Okay. The second one is mean square error. Acha, this is called MAE, right? So let's say if you go an interview and someone asks you that how you evaluated your model. Let's say you have written in your resume that you have built a regression model to predict something, right? Let's say predict sales, correct? So they may ask you on which matrices you used or on which matrices you evaluated your model. Another way of asking the same question is how you evaluated your model. Another way of asking the same question is how your model performed. You will say that my model's R square value is this much. You will say that my MAE is this much, right? So these are matrices, right, which we use to explain someone about the performance of our model. And that is the reason we call it all these as our evaluation metrics. Correct? For example, if you have to tell your marks, multiple ways of saying, you can tell your absolute marks, you can tell your percentage marks, you can tell your percentile marks, you can tell your rank, right? You can tell how what is your all those things, right? We are coming to it. I don't want to explain it right away. There are multiple things which will come mostly in classification. In regression we have less, but in classification we have so many concepts for evaluation, right? But we can explain our marks based on all these things, yes or no? Correct?
Yes.
Yes.
But which one is best at which point of time is a question which we need to answer. You understand what I'm saying?
Yes.
Yes.
Yeah.
Okay. Now that we will see in a moment. But before that, let me again define the second one, that is mean squared error. And this you will tell me, I won't tell. Mean squared error, or in short, MSE. Right? What is this? Tell me.
So it will be the square of sum of the square of error divided by the average divided by the number.
Mean of
Squared
squared
value of errors.
errors. Right? Now, what is my error again? Is it
Y minus
absolute? No, it is
y minus
exactly the error. So y minus y bar, right?
whole square.
Square and then mean. So mean, for mean, I'll have to do the same thing. I have to take the summation I is equal to 1 to n and then divide by n. Any confusion? Any confusion? Tell me. No? Cool.
No.
How
The
are
third,
these two different, Dhruv?
huh?
How
What?
are these two different in terms of usage?
I'm coming to that. I'm not talking about the uses for now. I'll come to that in a moment. Okay. Let's first see the metrics. Okay. The third one is root, mean, square, error, right? In short, it is called RMSE. See, short name also keep in mind. Why? Because the name is so large that people usually call it by this name. Okay. So if someone tells you MSE, suddenly you should think he is or she is talking about mean squared error. Okay. Now, can someone tell me what is root mean square error?
Root of the second case.
Yes,
Square root of.
exactly. So if I just take the square root of what is written here, right? So square root of, so this is nothing but root of mean square error. So I'll just copy the second one and write the same thing, right? Square. Cool. So let me write here that thing. Square root of mean of squared error. That is the definition, right? Now, why? See, you will tell me that Dhruv, one thing is clear, that you told me that we always need the error in positive, and that is the reason we have taken the positive here by taking the absolute value, right? Here also we are doing the square. That is the reason it will become positive, right? And here also, since we are doing the under root of a square, which is a positive, so mostly I have the option of taking the positive value. Correct? Yes or no?
Yes.
Yes.
So everywhere it is positive. That is understood. Then you will tell me why these three are different. What is the difference in these three? Can someone tell me what is the difference? Even before me explaining, just by looking at the formula.
So if the value is too small, then we may need to use the mean squared error.
Value is too small.
Yeah. The values.
What values?
Like the y and the predicted values are small, then while we are calculating, it will be too less, maybe like a 10 to the power of -6 or 7. It's not that much significant, right? So in
No, so
that,
error need not to be anyways. See, you want it to reduce anyways, right?
so something to be significant and which can be compared. So in that case, if we are making it as a squared,
Yes.
it will be.
You are in the right lines, but I'll just fix it a bit for you. Let's say I don't want any error in my, I just want very small error in my model, right? Let's say, correct? Then there is an effect of an outlier, or let's say some big error. Outlier is, as in I'm talking in the terms of, let's say, error, correct? Okay. Now if I have done the square, what will happen? My error will become larger. Yes or no?
Yes.
Yes.
Yeah.
In that way, if there is 2 and there is 3, correct? So 2 and 3 are looking very near to each other, but what about their squares? It becomes far more, even if there is a small bit of error. You understand what I'm saying? So 2 and 3, these are looking almost comparable, statistically speaking.
Yes.
Yes.
But what about their square? It is 4, it is 9. It becomes far you know, 9 is very far from 4. Yes or no?
Right.
Correct. So you can perceive it in that way. Let's say if I have a kind of an outlier. So if I have to tell you, it gives relatively high weights to the large error. Highest weight basically in all three, it gives relatively high weights to the larger errors. So larger error means out of 2, 3, which one is larger? 3. So it will give higher weightage to that and it will make it 9. So mean square error. You are not saying that your error is 9. What you are saying, your MSE is 9. Clear? Error is still same, but you are seeing that the evaluation matrix MSE is giving you this error to be 9. Understood? So whenever when you will use it, when you don't want the large error to occur, or large error are undesirable in that scenario, you will use MSE. Clear?
Yes.
Yes, no?
Can you explain it once more, Dhruv?
Okay. Let's say I am fine with small errors and I'm not fine with large errors. Large error means there is no thumb rule as such, but I'm just saying that I am not fine with large errors in my model. Okay. If I use any of these two, right, since it is in the same, you can say kind of, though those two are also different, but kind of in the same unit
Yes.
or same scale basically, right?
Yes.
In that way, the weightage would not be so great. You understand what I'm saying? So let's say if there is a small error, right, very small error, okay, or let's say a large error, what is the difference? I have said, let's say this is 3 and this is 4. This looks comparable, correct?
Yes.
Which one is large? See, this is relative. I cannot say that 4 is large and 3 is small, correct? Either both is small or both is large. This becomes your perspective. But I'm just telling you, if if I'm not fine with the large error, what I'll do? I'll choose a matrix which will scale up the large error in a way better than, or more than the smaller ones, right? So in that time, I'll be taking mean square error. So what will be the mean square error of this error, right? So that is, let's say 9, and this is 16. Obviously, I'm not considering the mean. I'm only considering the square part of it. Mean, correct? So let's say this comes. Now this is 9, this is 16. Now you are able to differentiate it properly, right? That you don't want this error and you can keep this error. You understand what I'm trying to say?
Yes. Now it's clear.
This I have showed you only 2 errors. It becomes more clear when you have more number of points. Let's say 10,000 points, 1 lakh points you have, right? It becomes clearly visible what type of points you want to keep, right? Which is giving a smaller error, and which point you want to reduce the error in the terms that it is giving the larger error, correct? So how will you do? Let's say in a way, MSE is a magnifying glass, which will give you a bigger picture of the same error. Error is not increased. It is just that this MSE is nothing but a magnifying glass, right? Magnifying glass, which will magnify the error so that it is visible. Understood?
Yes.
What is the error? Error is same. Error is same. This thing is error. Okay. Understood? So let me
Yes.
remove it. I want me to keep it. अच्छा रहने दो यार. ठीक है. You will remember when you will see. Okay. Now you said that, Dhruv, you have told that MSE is what is kind of a magnifying glass which will give more weightage to the higher error. We have got it. Now, can you explain what is difference between mean absolute error and root mean square error? Because now you have said that this is square, it is visible that it is square, but these two are in the same scale. Then why there is a difference? Yes or no? Correct. If this
Yes.
is 2, if this is 2, RMSE will also be 2. Yes or no?
Yeah.
Correct or wrong?
Correct, correct.
Correct.
And what is the difference? Anyone who knows math properly can explain the difference, when it will be a difference. Anyone wants to try?
It's because of a root of the numbers.
MSc will give a positive value. Sorry, it can be negative, but
RMSc will give the positive value.
positive value.
This can be negative, is what you are saying. MAE can be negative.
In absolute, we are taking magnitude, I guess. Yes.
See,
And-
this also will
No,
give
the
always
absolute
positive.
error also will be
Here
positive.
also we are considering, see, it obviously square root can be positive, negative both, but I'm saying that we will consider positive in our case, okay? Because error is error. We are just taking the magnitude of it, okay? So
Yes.
that is ruled out. Any other thing, just use your mind.
So the division it will be for RMSE is root of n, and for absolute it will be like 1 by n only.
Okay, let's see. Let's see. I'm just taking one example and it will be clear. So MSc, usually everyone, will give the answer why MSc is different from others, because it is the squared value, correct? The main problem occurs when I ask MAE versus RMSE. Okay. Give me one moment. I'll be explaining. Let me make a quick. So I'm assuming that this 1, 2, 3, 4, 4, 5, 6, 7, 8, 9, and 10. Okay. Now, let's say what I'm doing is I am just writing the error. Okay. Then I'm taking the absolute and then I'm taking the square. Okay. This is what I'm taking. It is not happening. Yeah. Just give me a moment, guys. छोटा नहीं हो सकता क्या यार? ये हो सकता है. ये भी हो जाएगा. Because it is copied. ठीक है. What I'm doing is I'm taking. Okay. Now here. Also I'm taking 3. Here also. Everyone on it?
Yes.
Okay. So on the first column, I'm taking the error. Okay. In the second one, I'm taking the absolute one. and in the third one I'm taking the square. Here also okay. Now let's say if I have error as 2. Okay. Okay. Error as 2. So 2, 2, 2, 2, 2, 2, 2, 2, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3, 3, 6, 3, 9. Only 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Actually, one more, just make one more. Okay. Here also I want 10. Okay. Now what will be the absolute value of this error? 2.
2,
What will be the square of this?
4.
So 2, 4, 2, 4, 2, 4. Right? So everywhere it will be like that in this particular case. Okay. Let's call it, right, my table 1. Let's call it table 2 and let's call it table 3. Okay. Since we have very less space here. Okay. So what we are trying to do is we are writing below. Okay. What will be the mean absolute error of the first table? Can someone tell me?
2.
2.
Hmm?
2.
It will be 2.
How?
Absolute value of all the errors is
So
2.
basically mean is 2, correct?
Yes.
Yes.
What about RMSE? Hmm?
2.
All of you got how he is saying 2?
Yes.
Yes.
So RMSE is also 2, right? So here, what is the type of error that we have taken in example? Hmm? Evenly distributed error. Then MAE and RMSE is same. Okay. Till now, so far so good. Any confusion?
No.
Okay. Let's reach out to another example. Now there is a bit of change. Let's say the 5 values 1, 2, 3, 4 and 5 is 1. Next 5 is 3. Okay. What will be the absolute? 1, 1, 1, 1, 1, 3, 3, 3, 3, 3. Okay. What will be the square? 1, 1, 1, 1, 1, 9, 9, 9, 9, 9. Okay. Now tell me what will be the MAE and RMSE?
A will be 2.
MAE will be 2.
Hmm.
2.25.
Huh? 2
RMSE
point something, right? 2 point
2.25. 25 something.
huh?
2.25.
25, right? Approximately, right? Approximately this, correct? Now you see the difference. Okay. Now let me take the third example and it will be crystal clear. Okay. Let's say out of 10, 9 values are 0. And the last value is 20. Correct? What is the value of the absolute one? This will be 400, right? And this is 0, 0, 0, 0, 0. Now tell me, what is MAE?
2.
We will
2.
And what is RMSE?
20.
6.6.32.
20. Who said 20?
6.32. 6.32.
What actually happened? Can someone explain me now the difference between MAE and RMSE?
For smaller value, there won't be much difference.
Mhm.
For the bigger value, it makes a very large.
No, it's not about smaller or larger value.
Depending on the distribution of the
Depends on
error,
evenly distribution of their.
Yes, that is the distribution surely, but what is the exact thing that you will tell? See, you have to go a bit in mathematics. See, what is the definition of RMSE? So RMSE, the square is what? Before root or after root?
Before.
So in MSE, what used to happen? Whenever we are taking the square, right, it will give relatively high weight to the larger errors, like we did in MSE.
Yes.
So if you see here, if we have outliers in our data or higher error, it will give you relatively higher weightage to that. Yes or no? Array.
Yes.
See here, na, the
Right.
weight, what is the MAE 2 and what is RMSE 6.32? It's 3 times and more. Correct?
Yeah.
So it is
Yes.
giving higher weight to the larger error. So when we will use it, again the same thing. We should use RMSE when we don't want large error to occur. Okay, so let me write it down. The reason you know, right? Squared before taking root, right? So I'm just writing since RMSE, okay, gives weights to large errors hence should be used when not high but large errors are undesirable. Yes or no? Tell me.
But though I guess in that case we better use MSE, right? So
Yeah,
that will
see, there are two points. I'll coming to that. Okay, so there are 2 points on which we have to consider the error matrices. One is interpretability. Right? And second one is sensitive to outlier, right? Sensitive to outlier, right? So let's say if you don't have any outlier in data, which one will you choose? So interpretability of mean absolute error is better, right? Then RMSE is better. Why? Because in this kind of in the same same scale, and then MSE. Okay, because it is not taking the same scale, it is just squaring up. What about sensitive to outlier? So MSE is most sensitive to outlier. Okay, then comes what? RMSE, and then comes the MAE. Because when we have an outlier, the ME remained same throughout. Yes or no? You understand?
Right.
Now there is a trade-off. Okay, which one you want to choose? It should not be that why we are using this when we had this. So it is always about the mix match. If you want more interpretability, now which one would you think is a better one? I mean, if you have to consider both, tell me.
RMSE.
RMSE.
That is the answer of your question. If you don't have any outlier, then what will you choose?
MA.
MA. And if you have, let's say, outliers on the both sides, and you are giving, you don't want outliers or something like that, or if you want to improve your models based on outliers, which one will you choose?
MSc.
MSc. Okay, understood? Is it clear? Would you explain to anyone which one you will use and at which particular scenario?
Yeah. Yes.
Okay, that was about the error in your model. Okay, I said there are two ways to become great. One is to reduce the error. That means if you are evaluating your model based on the error, you want your error to increase or decrease?
Decrease.
Decrease. So doesn't matter if you are taking ME, MSc or RMSc, you want these matrices to show less value. That means less value means better the model. Okay. Now comes the other type of evaluation metrics, right? Those are R square and adjusted R square. See, adjusted R square is not spoken much in tutorials. Usually you will see R square much, okay, but I think you need to know adjusted R square also, and that is the reason I'm teaching here. Okay, now coming back to it. Okay, see, what is R square? First of all, we saw what is correlation coefficient. What is correlation coefficient? It gives you the strength of the relationship,
Strongly things are correlated.
right? And what is the range in which R ranges from -1 to 1? Yes or no?
Yes.
Yes.
So what is the range of R square would be then? Zero to 1. Understood? R square means if you do the square, then -1 would what become anyways 1. 0 will remain 0, right? So the range becomes 0 to 1. Clear? Not talking about the range, coming back, what is it? So R square, R was coefficient of correlation coefficient or coefficient of correlation. R square is called coefficient of determination. Understood? What is it? What is it? And how you use that in model? If you remember, I told you that variance gives you how your data is spread. Covariance tells you about the relationship of two variables only in the terms of direction. Then comes the correlation, right? Correlation not only gives you the direction, but also tells you about the strength, right? So direction plus strength is given by correlation. And comes the regression. Now the regression, in order to evaluate the regression, we need to have some coefficient. So this is the regression coefficient or coefficient of determination, in which it will tell you about how well one one variable explains the change in another variable, right? I told you with in addition to what direction, strength, it will also tells you change in one variable, how it affects the change in another variable. And that is exactly what we are doing in regression. Yes, no? We are just taking the value of x, we are extending it, and then at certain value of x, we are checking what is the value of y, no matter how many x's we have. If we increase the value of x, I mean number of x's, so we are saying that, let's say if I have let's say loan of previous loan of 1 lakh, okay, my CIBIL score is 890, okay, and something like that. What are the, can you tell me the percentage probability of which my me getting loan, right? That kind of issue. So you have multiple x's, but does it change? So it also tells you about how this percentage is related on the individual or independent axis. Understood?
Right.
Right. So this, there should be a measure as to relate or to find out the strength of what, this whole process, that is regression. And honestly, I tell you a secret, regression is not a machine learning concept, it is a statistics concept which is borrowed from statistics to machine learning. Okay, mostly if you pick any good stats book, you will find regression in it. But since it is common, I am teaching you in machine learning, but that doesn't change. Okay, you have to keep one thing in mind, that as we have correlation coefficient, similarly we have coefficient of determination. Okay, understood?
Right.
So
Yes.
you need not to know the formula, or no one will ask you the formula, but anyways I'll tell you. Okay, okay, so that you have that in your notes at any point of time. Anyone remembers correlation coefficient formula?
Covariance of xy by sigma x sigma y.
Yes, I also know only that much. Here r square is given by, if I remember correctly, I'll have to see the handout maybe, is sum of square residuals upon sum of square total. Okay, if I remember correctly. And what is that? That is 1 minus sum of square residuals is SSR. If you remember, what was that? Y minus y bar square. Yes or no? Summation of this.
Yes.
Correct. And now SS total is nothing but summation of y minus this y bar. I mean y cap you can think it as predicted y. This is average or mean, right? So this you can tell sum square total. So this is the formula of r square. Okay. Another way of looking at it is, this is in 1 minus, right? So okay, another way of looking at it is, if you solve it, the numerator, right? So r square can be given as unexplained variance upon the total variance, or right, total variance. Okay, clear? So sorry, this is 1 minus unexplained variance upon total variance. What does that mean? If my r square is more, that means my model is better. Yes, no?
Yes.
I'm able to explain the variance better. Yes or no?
Correct.
Yes.
You
Correct.
understand what I'm trying to say? So that means the way we were calculating the coefficient, correlation coefficient, and it used to come as 1 or 100%. Similarly, it will come as 1 or 100%, in between 1 or 100% to 0 or 0%. Okay, so let's say if you have got the R square value of 68%, that means you are able to explain the Y with a confidence of 68%. If I have to put it in a line, right? That means you are 68% accurate in explaining Y with the help of what? The value of X. Does that make sense?
Yes,
This
yes.
Yes.
correlation also talks about the relationship, right, between two variables.
Not, see, it is about the strength. Does it tell you how Y or another variable is explainable in terms of another variable? There are two variables there also. It just tells you the strength of the relationship, how it is correlated, right? But changing one variable, how much change another variable will happen, does it tell you? No, it doesn't. One unit change in one variable, how much change in another variable is given by regression. It is just the extension of correlation. Understood? And that is the reason we are using R square. Got my point?
Okay.
Okay. Now there is one more concept here, adjusted R square. Adjusted R square, right? Now, very importantly, I tell you one story. Usually people use this to fool their managers and their clients. In real life, I'm telling, right? What usually happens is, if there are, let's say, 5 variables that you are using to predict Y, let's say x1, x2, x3, x4, x5, I'm not naming it. Let's say sales is dependent upon 5 different types of variable, correct? Or yesterday we were talking about stock price. So stock price is dependent upon 10 different types of variable, right? Now let's say if I add one more variable to it, R square will always increase, always, even by a small bit, it will increase, right? So if you have to increase the accuracy, let's say your manager had told that, see, your model is giving 65% accuracy. Till tomorrow, can you try to increase it? I try. I know that my variables are not so good, so I cannot increase the accuracy. So what I'll do is I'll make a derived variable or something like that, and I'll add to that variable. So instead of 5, now I have 6 variables. Whenever a new variable is coming, it will always increase. Why? Because it is increasing the variability, total variability it is giving, increasing. So R square value will always increase. So in that way, even a small bit of increase, you will be happy. Your manager will be happy, client will be happy that yes, from yesterday there is a shift from tomorrow. To counter that, you should know adjusted R square, right? So what is adjusted R square is, everything is same as R. It one thing is more here. So I'm just giving you one example first, and then I'm coming to that. So let's say iteration 1. Iteration 1, I'm just naming it. You can name it cycle 1 or something like that, or anything you name it. I'm just naming it iteration 1, in which I'm using 5 variables. Okay, and R square value is giving me, let's say, 68%. Okay, I added one more variable. Now it became 6. Now it is giving 68.9. Okay, I have added 7. Now it is giving 69.2, something like that. Okay, but if you see adjusted R square, if whatever the variable I have added, so here I have added 1, here I have added 1, right? I can add 1, 2, 5, 7 together. It's not that I have to add only one variable at a time. I can add as many times. But whatever variables I have added, if that is actually helping me predict Y, then fine. Otherwise, it will penalize me for adding a variable which is not helping me find Y. You understand what I just said?
Not really.
Okay, so let me tell you. For example, adjusted R square, you can imagine in real life, I'll relate it with the story. For example, adjusted R square is like your parents, right? Whenever you are adding a new friend, okay, whenever you are adding a new friend, if he is good for you, good for your future, then fine. Otherwise, if she is just eating your time and taking you in a wrong path, something like that, you may feel that okay, there are more friends, but if those are not useful, it is not useful as it is. So your parents, adjusted R square, will penalize you or your score because of this added friend that you have got. Understood? So in other words, adjusted R square will only increase when the added variable is actually useful for you to predict y. Otherwise, it will decrease. I said R square can never, decrease with the add of variable. It will only increase, or at least even a small increase, I'm saying. But adjusted R square can decrease also with the addition of a variable. Understood? Tell me.
Yes, Dhruv.
Okay.
So how it can decrease if you can explain?
Okay. I'll come to that. Okay, I'll come to that. Before that, you understand how is it useful? First of all, it tells you which variable is important and which one is not. Indirectly, yes, no?
Yes.
Bolo na? Yes, no.
Yes.
Can we use it in our EDA? Not in our EDA, but even after EDA, we can use it to select variables.
Yes.
Right.
Yes.
I know the process is long. Let's say you have 32 variables. First of all, you have to choose the best variables, and then one by one, you have to add multiple variables. Then to see whether that variable is, that variable is useful or not for your model. I know that process is huge, but just assume you can use it at least if you have one or two variables that you want to check. Obviously, you can do that. Yes or no?
Yes.
Correct.
So nowhere you will see this written that you can use it to select variable. But I'm telling you can do that because we do that in real life scenario. Okay, so what we do is, let's say if I have calculated R square, okay, R square, when we have independent variable as x1, x2, x3, for example, right? We are going to see everything, right? When we are going to see these things, okay. Now, x1, x2, x3, I have taken. Now I have calculated R square. I have got, let's say, 78%. Now what I have done is I have added a one more variable without knowing or without realizing whether it is useful for me to predict y or not. You understand? Without even calculating or guessing whether it will be useful for my y or not, what I have done is I have taken, I have taken a new variable x4 and I have added to my independent variables list. Clear?
Yes.
So if I have done that, my R square will increase even by small bit, but just for the sake of understanding, I am saying that it has increased for 1.5%. Okay. So my point is R square will always increase with the increase in variable, even by small bit, but adjusted R square, right? Adjusted R square will only increase if this variable is useful. If it is not useful, then it will penalize the model for adding a new variable, right? So it will penalize, and you will see that, let's say here the adjusted R square was 77.8%. Let's say I'm taking an example, and this variable is not useful, then it becomes 77. What will you conclude? What will you conclude if you use adjusted R square in addition to R square? What will you conclude? That this variable is not useful.
X4 is not useful.
Then I should not use it to predict Y. Correct? This is for you to understand. I'm just going in depth because I have seen, even data science guys, or even in production, in my team also, people are not using this metric to evaluate the model. Not using at all. Not talking about you guys or whoever is doing the project. I'm talking about whenever we are building the product also at that point of time also. Why? Because they fear. Because they fear that their falsehood will be caught.
So in that case, always we should use adjustable R square, right?
Adjusted R square for your concept. Whether you should use it or not, I leave it to you. I leave it up to you to decide. Right? If you are stuck somewhere and your manager is someone who is telling that you have to give me an increased R square value, then obviously what you have to use? R square value. Correct? You cannot say today it was 77.8 and tomorrow it has reduced to 77. Correct? He won't be happy if he is not from data science background. That is how it works in our industry, right?
Correct.
But just for conceptual part, I just told. Now comes the part, how is it done? How is it done? Okay. So first of all, it is denoted by this, like this. So adjusted R square, R bar, and then square. Okay. This is just a denotion. See, again, you need not to know the formula, but then again, I'm writing, right? So SS residual, right, upon SS total, right? So that was our R square concept. But if we divide by degrees of freedom, right, DFE, and I'm coming to that, what is this, right? And this is total degrees of freedom. Now you tell me, if I increase the variables, my degrees of freedom will increase.
Yes.
Yes.
And it is in division, if you see. So what it is doing indirectly, it is penalizing for every increase in variable. Yes, no.
Correct.
Now, if this value is not increasing, by a certain, you can say, what do you say? Let's say if I'm dividing something by 1.5 and I'm multiplying also, if my multiplication is not more than my division, then my division will overpower.
Yes.
And then my overall fraction will be less. Overall, I'm saying.
Yes.
That is on that principle only adjusted R square works. So that means if you are just increasing for the sake of increasing, you are just increasing the degrees of freedom in any given set or any given setting, then obviously you are not adding value, you are just adding numbers. And in that case, it will penalize you for adding number by dividing with the degrees of freedom. Is it understood?
Please explain once more.
Okay. So what I mean to say is, if you see adjusted R square, penalizes for every increase in variable. So I said earlier you were using x1, x2, x3 to predict y. And it was giving you some value of R square. Now let's say you are using 4. This fourth one has just come, it is not helping y. For example, there can be multiple variables which is not related, correct? You understand? So for example, there are some variable which is not useful to predict anything. Let's say tomorrow's rainfall, right? Tomorrow's rainfall, is it related or is it dependent upon how many umbrellas I have at my home?
No.
Oh,
You understand what I'm saying? But since you have Python and people use anything and everything in their model. So R square, even if you use number of umbrellas as a predictor in order to predict the rainfall, right? Then also R square will increase. Even if you add this, you can add humidity, you can edit, something like you can add these three. Instead of that, you can also add, in addition to these three, you can also add number of umbrellas at any individual's family, and then you can see the R square, it will increase even by a small bit, then also it will increase, it won't decrease. Correct? But if this is not helping me, then this is not useful. Correct? That my model is getting affected. So what should I use? I'll use adjusted R square. And now how adjusted R square will work? Now understand this, by addition of this variable, my degrees of freedom has increased or decreased?
Increased.
Right? And this is adding to the variability, right? Now you understand this. If the increase of this, addition of this variable is not affecting, the prediction, that means this variable is useless.
Yes.
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 In a way, if you see, no variable is useless, because there is a, statistically speaking, how will you measure the variance, or how will you measure, you can say, the anyone's effect? You can measure it either from 0 or 100%. 0 means no effect, 100% means full, you can say it is helping properly, 100% helping, right? So in that way, I'm saying if any addition of a variable, if it is not helping by what it should help, correct, then it is not useful. It should be penalized just for the adding, just for the sake of number. If you are adding, it should be penalized. For that, adjusted R square has an option of penalizing you based on the degrees of freedom. Correct? So if you increase the degrees of freedom without adding value to the variable, or without adding value to the predictor, it will penalize you. Understood?
Based on your upper formula, means whatever you have mentioned, so how it affects, if you can explain.
Based on upper formula. Okay. So see, there is a division. Degrees of freedom is divided, is in the division, yes or no?
Yes.
Right? So if you increase the degrees of freedom, correct? See, obviously increase in the variable will change this and this also. Correct? You understand?
Yes.
So in order to, so we are seeing the collective effect is what I'm saying. And that is the reason I said that we are multiplying something, or we are adding some value by increasing this, yes or no?
Yes.
And we are dividing. What we are dividing? We are dividing with degrees of freedom. Correct?
Yeah.
So if your division is more than whatever you are adding value, then your overall value will decrease or increase? Decrease. Correct? Similarly, if your added value is more than the added degrees of freedom, the overall value will increase or decrease? Increase. Correct? Increase. So that means adjusted R square will not always be less. I'm saying it can increase also. Let's say if the added variable is very good, correct? Very good. Let's say my spend is based on the number of members in my family, right? And this is the new variable I have added, and Y is my spend. Now this is a very good variable, and this is affecting Y with very good things. Then my adjusted R square will also increase. R square will also increase, adjusted R square will also increase. So whenever you are considering you have to consider both. Okay, just give one moment.
Yes.
Let me show you in handout. Let me show you. There I have demonstrated this. Okay, so see this adjusted R square. So you have this degrees of freedom divided. Okay, now what is that degrees of freedom, right? Degrees of freedom. Okay, so
Minus
okay, there are 2 degrees of freedom, numerator and denominator. Okay, so you see here, this is nothing but n minus p minus 1. I'm coming to what is, and this is n minus 1. Okay, why it is so, please don't ask, because we are not going into the depth of this. There is a very big derivation of this. I don't want to get into this. Never you would be able to never you are going to use the formula, at least. Okay, so just keep it till here only. Okay, what is n? Total sample size.
sample size.
I think it is written. Okay, don't need to write. So if you see, if you do it, this will come in denominator, this will go in numerator. So n minus p minus 1 came in denominator, and this went in the numerator. Okay, clear? So this is how. Most important part is not the formula or anything, but to understand. Okay, so you have to understand, every time you add an independent variable to a model, the R square increases even if the independent variable is insignificant. It never declines. Whereas adjusted R square increases only when independent variable is significant and affects dependent variable. Correct? Now let's say there is one variable, only one variable, and R square is 67.5. Your adjusted R square is 67.1. You have to understand, adjusted R square is always equal to or less than R square. Okay. Now, if you have two variables, your R square has reached, increased from 67.5 to 85.9. Okay. And this also increased from 67.1 to 84.2. What will you conclude? This addition of one variable, whatever variable I have added, let's say fourth variable or fifth variable, whatever one variable I have added, is of good use. Why? Because both R square and adjusted R square both are increasing. Right? Let's go ahead. Let's say that I again added one variable. Now my R square is again increasing. I said it will always increase. It is increasing by 3%. Okay. And what is the adjusted R square? It has decreased. That means the second variable which I have added is not it is not useful or insignificant. Is it clear?
Yes.
Tell me one thing. Can R square be negative?
No.
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 What about adjusted R square?
Yes.
It can be negative. This question was asked, and very confidently in interview around 4 years ago it was asked. Okay, so in interviews at that point of time, and I thought for a while that, see, R square, there is a square. Okay, so I knew R square is not negative because it ranges from 0 to 1. Okay, because it is the square of the correlation coefficient square, let's say. Okay, and that ranges from -1 to 1. So square will be ranges from 0 to 1. It is non-negative, I told. Okay, but adjusted R square, I never studied in any book. Okay, whether it is positive or negative. Okay, and then I said, see, let me think about it. So it is adjusted R square. So R square is there, so it will be always positive. So I said positive, which was the wrong answer. So that is the reason for you guys, I have written it that adjusted R square can be negative, right? Whenever R square is close to 0, right, then your adjusted R square can be negative. This is a interview question. They may ask this question if they want to go deeper into this. Okay, adjusted R square is clear.
Yes.
Okay, one formula, if you want to if you want to relate, so this formula you can keep in mind, because it adjusted R, it denotes adjusted R square with R square value. So if you know R square, you can calculate adjusted R square. If you want to write it your own formula, okay, function to calculate adjusted R square. Is it clear?
Yes.
Any confusion till here?
Dhruv, one clarification. Say, suppose if we have to determine if a variable is dependent or independent, we need to find out the correlation coefficient, right?
Correlation, dependent or independent? No, see, dependent or independent is not something we determine. Clear?
Okay.
So we tell, right? And we assume that my y is dependent upon all these variables. Correct? But yes, what you are saying is strength of the relation. If you have to find out, then you find out through correlation coefficient. Okay. But if your relation is not strong, or in other words is weak, then you cannot say that this is dependent variable.
Yeah.
Things that doesn't work in that way. So independent and dependent is kind of a theoretical concept in which we assume before applying regression, it is in the assumption of linear regression that the variable which you are trying to predict is obviously dependent, and the variable from which you are predicting this are called independent. Right? So that is the concept. Now all the variables which you are using to predict y are called independent variables.
Okay.
Now no matter which value you choose, okay, it is for you to decide whether you are taking any value which is affecting it much or has weak relation, but that doesn't tell that it is a dependent variable. Make sense?
Yes. Thanks.
Okay. Okay, now to collate, what are, if someone asks you, tell me, question, what are the evaluation matrices you have used for your
Model.
for your regression model, not model. See, for classification we have other evaluation metric, right? This is for regression only. No matter which particular regression you use, the same you will use. So how many evaluation metrics we have studied? So you should always start from R square. Then you can say what? Adjusted R square. And then you can say any of the error metrics out of MSE or MAE
RMS.
or RMSE. The best answer that they are looking for is this name and any of this name, let's say this. So if you give these two, you are good to go. Okay, tell me one thing. If R square value or adjusted R square value is more, what does that signify?
Model is more accurate.
Model is more accurate. So I mean, better model has more R square value. Similarly, since these three gives the error count, or you can say this is a measure of error, so obviously I want it to be less. So you have to understand, first two are accuracy, kind of accuracy of your model. Last three are the error matrices. Okay, so you cannot say that my model was best because it was giving me 89% ME or 89 as ME, something like that. Okay. Is it clear?
Yes.
Okay.
Sorry.
Okay, let's go ahead and see what is multicollinearity. What is multicol? Can someone tell me what is multicollinearity? Hmm? What is multicollinear? Can someone try at least? See, in data science, when you go for an interview, right? So what happens is half of the time, sometimes I'm saying, you will be asked few questions, let's say, which you are not knowing. Okay, then also you have to try. Okay, so first of all, let me define what is multicollinearity, right? So what we have said in the setup that there are multiple independent variables. There is a dependent variable. Yes or no? This is what I have said. And I have said that dependent variable is is actually predicted using all the independent variables.
Correct.
Now, what happens if one or more, let's say one or more uh, not one more. So let's say what happens if one independent variable is highly correlated with, right, that, with one or more independent variable again, right? What will happen? Hmm?
We don't need.
So that means if this is the thing, then one independent variable can be predicted using another independent variable.
Yes.
Right? You understand? Now see, the problem with this is, though it may not affect, see, I'm giving a very practical approach or very matured type of answer in this particular thing, not a very basic one, because I think you guys know what is correlation and all. You have gone through, we have gone enough in enough detail. Now you know what happens actually. See, what happens actually is whenever, right, whenever this happens, it is not always affecting the, you know, model's accuracy. It is not, if someone tells you that my model's accuracy is getting affected, that is the wrong answer. To be honest, I'm telling you, I've seen people giving this answer. That is not the answer. But it affects the variance associated with the prediction, right? And also it is affecting the quality of interpretation. So basically we are interpreting my y. Yes or no?
Yes.
Right.
Right.
So quality of interpretation of my, predictability, it is affecting, because what we are doing in regression, prediction word we are using, but are we actually predicting? No, if you see closely, what we are doing, we are generalizing it. Correct? You understand? So if I have to explain, I read somewhere, I am failing to recall, but I'll give you this example. Let's say if there is a catch, all of you see cricket, if some batsman has hit very high, now there are three fielders coming for the catch, right? And there is a tussle and all of them fall and someone took the catch. Correct? Someone took the catch and now left the ball there and there, and then because there are three fielders involved, we are not able to understand who actually took the catch. Are you understanding this fact? So what actually changed? Yes, the batsman is out because the catch is converted. Somehow we got to know that yes, the catch was taken. But are we able to understand who took the catch, how it happened, all those things? We are confused, right? If we are watching, we are confused. Yes, no.
Yes.
Are you able to understand what I'm trying to say?
No.
Is it that we don't understand which independent variable is actually helping?
So if you have, see, it is same thing that let's say three fielders all are claiming that they have taken the catch, right? That means more than one variable. If all of them are saying the same thing, we would be confused. My model would be confused, right?
Yes.
Correct? Because all of them are helping the target variable in the same way. So why to increase the variability? Let's drop one or more and only keep one, because it is helping in the same way. You understand? It is me saying that if somehow, if I'm God, what I'll do is, if three fielders reached there, so magically I'll disappear two, so that one can comfortably take the catch. Catch is also done. And we are also able to justify that, okay, he has taken the catch. There is no discrepancy.
Yes.
I'm making it a bit simpler. Don't relate it 100%, right? But I'm just trying to give you some sort of interpretability from this particular statement which I made. I have seen people giving this answer that it will affect my model's accuracy. It won't. It won't. That is a wrong answer. Write it down in your notebook. If someone tells you that it will affect the model's accuracy, it won't. Okay? Because in our concept, which we just took, no matter who took the catch is gone. We are just confusing who. All of three are claiming that I have taken the catch. Batsman is anyways out. Now we have to justify with whose name against which it will be taken caught, right? So that is what. So accuracy is related with whether the batsman is out or not. So batsman is out, right? But which variable or which fielder took the catch is what we are concerned about now. Then someone may ask you that it is not helping me or it is not affecting me, affecting the accuracy. Why should I worry then? Right? Because your model is not trustworthy then. If you are not removing the multi-collinear variables, then your model, right now it is giving a good accuracy, but it is not a good generalization. It has not learned enough. Tomorrow it may give a very weird results. You understand what I'm saying? What is a model? What is a model? Model is nothing but a generalization.
Yes.
How our child learns? They do generalization. What is generalization? if there is 2 plus 9, I have, it will be 11. See, you have to go to very basic. How we understand this is 2? Because we have taught that whether it is 2 or this or this, we will consider it as 2. Yes or no? That is nothing but pure generalization. Yes or no? If it is 9 or written like this, or something like this, you can write, it will be 9 only. Okay, so these are two generalization. Then what is another generalization? Whenever you will add to these things, then some other, you will have one as one left, and then all those things, right? And then you will keep one as those things. So they are not remembering it, but in a way they are. You understand? That is what learning is. Even in real life. So if your model is not able to generalize enough, is that accurate?
No.
No.
So you want your model to behave accurately, right? Behave accurately. Then what will I do? What is the conclusion? So what is the conclusion if I don't want the multicollinearity to happen? First of all, how will I detect the multicollinearity? Multicollinearity, how will I detect? There are multiple ways, two of which I'll teach you. Okay, one of which is now, detection. How to detect? So detection, let's see. Correlation matrix. So correlation matrix, let's say you have, this is, okay, one. So this is 336. So 1, 2, 3, 4, 5, and 6. Okay. So let's say this is x1, this is x2, this is x3, this is x4, this is x5. Let's say y. Again, x1, x2, x3, x4, x5, and y. This is what will be my correlation matrix. Correct?
Yes.
This will be, diagonal will be 1.
Yes.
Because this, if I talk about this, this is x1 versus x1. So any variable with itself will be 100% correlated.
Correct.
Right.
So I won't see, I will just leave this one, because this tells me about the correlation of dependent variable with independent variable. Rest, I'll see throughout all the cells, and we'll see whenever I'm getting a correlation, strong correlation, let's say 0.8, 0.9. So these are my red flags, right? These are my red flags. I should be able to understand that these are my red flags. Then what will I do? These are the case of multicollinearity, right? These are the case of multicollinearity, correct? Okay, not here, but let's say x5 and x2. What is this? This is y and x3, correct? So my bad, I painted it that way. Okay, so I'm talking about this because this tells me about x5 and x2. Similarly, let's say here there is some value which is very strong. Then you have to think about it, that if it is so much correlated, then this is a case of multicollinearity. Understood? So all of you know this, so I need not to explain how will you plot correlation matrix, how will you see. Only thing to note here is you have to see between independent variables, not with y. Okay, if it is with y, that is a good thing, correct?
Yes. So you mean to tell, like, if an independent variable is dependent
With
those,
any of other independent variables.
correct. So in that case, one of the variable can be ignored.
Oh, one of it can be ignored. Okay.
To make more generalization.
More your model more accurate. Okay.
Okay.
So sometimes even at the cost of your accuracy. Because see, there is a famous saying that even if your model is not performing good today, then also you want it to learn properly so that tomorrow when you put it in production and every month new data is coming, it is able to generalize better. Correct? So even if your child is failing in pre-boards or unit test, you want it to perform in throughout the life. Correct? If you are teaching them the mathematics addition, right? You don't want to suffer in future. Correct? Whenever they are adding something. Okay. So one way is correlation matrix. Okay. And how to see in between that. So that is already explained. So I haven't written there. Another way is variance inflation factor. There is one concept, variance inflation factor. Okay. Let me write it down. And this is called VIF. We called it VIF. You will also call it VIF. But once for all, let's know the variance inflation factor. अरे यार fraction, why I'm writing, क्या लिख रहा हूँ अभी? So we call it VIF. Half of the time I used to call it variable inflation factor, but it's not, it's variance inflation factor. Okay. Now it tells you how much actually the variance of the regression coefficient increases if your predictors are correlated. That means higher the value of VIF, more correlated your independent variables are. Okay, so let me write it down so that it is more interpretable for you. So basically VIF, tells about how much the variance of an estimated regression coefficient increases. What is a regression coefficient?
R square.
R square.
R square.
Okay. Increases if what? Your predictors are correlated. Predictor is another name given to
Independent
variable.
Right. Are correlated. That means, okay, first of all, let me write the formula of VIF. This is given by 1 minus R square. Okay, R square, you know, right? So let's say if R square is 1, what will be the VIF? Infinity, correct? And what about if R square is 0?
1.
So what is the range of VIF? It ranges from 1 to infinity. The minimum VIF value is 1. Now, right? Now, when we should, right? When we should avoid any two variables. So larger the number of, or larger the value of VIF, the highly correlated two variables are. You understand what I'm saying?
Yes.
So this R square, don't consider it with respect to Y. This we are talking about with respect to two independent variables, because with which I'll can calculate the VIF, yes, no?
Yes.
Two or more independent variable basically, right? So higher the value of VIF, the highly correlated variables are. But there is a thumb rule. So VIF, so near about, just giving thumb rule, don't take it as a rule, but just a thumb rule or just a reference, you can say, near about 5 or more you can think it as a multicollinear, right? You understand? The way we took the correlation 0.75 or more as strong, it's not a rule, it is just a thumb rule, correct? Or reference, which we all statisticians have to keep in mind. Okay, understood? So these are the two ways in which you will you will do, right? You will detect whether it is. Another way is, once you have detected, okay, how will you prevent it? How will you prevent it?
Here, now one doubt, Dhruv, here VIF will not say which variables are dependent, right?
But right, 5 variables, if it is correlated, I mean, if you are using 2 variables and if it is correlated, then these two are correlated, correct?
Yeah, correct. So that means we have to calculate for all the variables and see.
Not all the variables, not all the variables, I'm saying. This is just a tool given to you if you want to find out the multicollinearity, if you are suspecting. So anyways, you have this heat map, right? Heat map, you can plot for all the variables, and let's see if came as 0. Let's say 9. Okay, now x3 and x4 are what? Correlated.
Yes.
That means it is multicollinear also. So to edit question, you can calculate the VIF, correct?
Okay.
So in that way you will get 10 variables here, then you can think. So here x4 itself is not something, it in relationship with x3, right? So out of these two I can keep any one, right? That is what I mean to say. Okay, understood? Yes, no?
Yes.
Yes.
How
Yes.
to prevent? How to prevent? The one thing I have already mentioned, drop it. What else?
See here, dropping one of the variables. How do we decide which one to drop? Or it is
Anyone.
Okay.
Both are telling me the same thing, right? That means I can drop any of it. You understand? I told you, right? 3 people are taking the catch. Okay, I know if there was one people also there, he would have taken the catch, considering the ideal scenario that he will always take the catch. Yes or no?
Yes.
Whether I drop another 2 in any order or something, which one I want to keep it there as a god, I told you, right? So I can keep anyone. Another way is feature engineering. What do I mean by that is, let's say if you have 2 variables from this, let's say I'm talking about x3 and x4. If it is this pair, x3 and x4, what I can do is, let's see, I can do some feature engineering, can combine both to make a new variable. For example, if I have BMI, if I have weight and height, okay, and I have got that this is highly correlated and is kind of uh, coming in multicollinearity, and what I can do, I can combine it and make a new variable called BMI. So instead of using weight and height together or separately, I can use BMI as a new feature, which is a combination of both. Correct?
Yes.
We are
Understood?
preparing another dependent variable.
Instead of using both, I'm preparing another variable. Correct? Shock हो गए क्या? Are you shocked or what? Rocket science, I have spoken something very strange or what? This example also I have taken many times. Yes, no?
Yeah.
Bolo na yaar.
Yeah, good example.
not good or bad, but I'm saying that I've repeated it. So you should be knowing by now. Don't get surprised. After 1 month, you will fail to recall me that there was some guy named Dhruv. What is this, yaar? I am not fine with this. Abhi yaad aa raha hai? Who asked this question? Now you remember I spoke about it multiple times, at least 3 times in the past, that using weight and height, I can, build a new feature or new variable called BMI.
Dhruv, I was just
Not to
thinking
speak.
of drop of one variable. So in that case, can we consider like the correlation between that independent variable and the dependent variable? And if that correlation is more, we can keep that variable and drop the other variable.
Sorry, what you said?
So consider like there is independent variable 1 and 2, and we have a dependent variable y. So if the correlation between x3 and yeah, so if it is consider
So
like
you will
that,
drop this and you will keep this.
yes, is it
that you can obviously do.
okay? So in that case, if we are dropping that x4 and keeping x3, will it make any difference?
Yes, it will make a big difference, because if you are losing, if you have to lose 1 out of 2, so you should lose the weaker independent variable. That means weaker in relationship with your target variable.
Yeah, just want to make sure. Yeah,
that is one strategy that you can think of. Okay.
sure.
Okay, I think most of it is. Let me quickly go through the handout. Okay, and let's go from starting. So read from the handout only when you feel that I am, I'm not feeling like I know anything, or you tend to forget. Otherwise, our class notes are better. Okay. In my class, I usually used to give this as an assignment, but since now I have to upload it today, so you can see this is the code to write adjusted R square. Okay, so this is my own function. You can also write your own function, okay, to calculate the, just you have to deploy this particular formula, that's all. Okay.
Yeah.
Mean absolute error matrices we have already seen. Assumptions of linear regression, these are some of the theoretical question they may avoid. Sorry, they may ask. They may ask these questions. Okay. Acha, yes. So VIF, I told you how to calculate using formula. You can use the function, function from stats model, variance inflation factor is, and you can simply utilize it to calculate. Okay. Okay, you can utilize. I think I have covered everything from education perspective. See, this was if it was it had to be covered in stats, then it would not have been so long. Okay, so I wanted to wait in machine learning in order to be more proficient with the programming part, or you can say more proficient from the conceptual perspective, because linear regression as a machine learning model, it is one of the basic models that you would be using everywhere, right? In prediction, even later part in your batch, you will be having time series. Okay, I won't be teaching time series, but time series will be taught, and that is also based on regression. What is time series? This is just that your dependent variable is time dependent, right? Stock price or something like that. Understood? Okay. Yeah. Any questions? Can we go ahead and now just do something hands-on?
Yes.
Or you want to take a break and then can we do?
Yes.
ठीक है. Chalo, let's do. Okay, so okay. You guys are going to help me, right? I'm very bad in programming, so you guys are going to help me. Okay, chalo. Let's start with import. Imports. So what are the things that we would be needing? So import numpy as np. Import pandas as pd. Tell me, what is np and pd? Can anyone explain what is np and pd?
Aliases.
Alias name. Yes.
Can I import numpy as pd and pandas as np?
Yes.
It is just a name given to those numpy and pandas.
Yes. Okay. These are the import. What else we would be needing? Let's import seaborn, right? Seaborn and matplotlib. I'm not sure whether we'll be using. Okay, let's import some visualization. Import matplotlib lib.pyplot as plt. Okay, all of you would have remembered it, yes, after using it so many times.
Yes.
Seaborn as SNS, right?
Yes.
Okay, so I think it is looking good for now. We'll see if we need to import anything, then we will come back and we'll import that here. Okay, anything else? Okay, let me suppress the warnings. How can I suppress the warning? Anyone?
Inline.
Huh? So I have to import warnings.
That you need to make it as blank or something.
So warnings होता है या warning होता है यार? I think let me see. अभी warnings डाला है तो filter.
It is import warnings.
It's S, filter warnings, and then you have to ignore, right? So ignore.
Yeah, ignoring that.
Okay, चलो इसको करते हैं. हो जाए यार. Yes, done. ठीक है. What is the next step? Hey, you have to speak now. See, after teaching this much,
Importing the data set.
I will stop here. Then I'll give it as an assignment. Huh? Import what?
Importing the data.
Data set.
Importing the data set. Okay. So how will I import? So this is advertising. Okay. So let me name the same. Okay. So or let me name advertising. Okay. So advertising. Okay. PD. So pandas has read CSV, right? Read underscore CSV or dot CSV?
Underscore.
Yes. Last batch, one people had a confusion. Okay. So advertising dot CSV. Okay. So run this. Okay. It is done. Now let's see advertising. Okay. See the data. Okay. This is our data. Okay. Now sales is dependent upon, revenue or you can say advertising from TV, radio and newspaper. Okay. And then sales is dependent upon that. Okay. What can we do? What is the next step? To understanding the data, right? We have to understand the data, correct?
Yes.
What are the different ways to understand the data or picking the data?
First is to determine the data type.
First of all, shape, right? So tell me, shape के बाद ये आता है क्या? This brackets come after shape?
Brackets
Yeah.
occupied.
No,
No,
it should not be there.
No brackets.
Okay. What else?
Type of data. .info.
.info. Right? .info. See, it is very easy, right? Now .info, as we spoke yesterday, also gives individual variables data type. Okay. And someone was saying describe. So let's say describe also. So advertising dot describe. अब describe में आएगा क्या? Describe में आएगा क्या ये?
Summary आएगा.
Main
नहीं,
media node.
this no wait.
No.
This bracket will come or not?
Yes.
आधे लोग confused हैं यार.
Yes.
This you should be knowing till now. Okay. What are these? It is 5-number summary plus few more things, right? Count, right? Mean, standard deviation, minimum, 25%, 50%. This is not percentage. This is percentile. Okay. 75 percentile and maximum. Okay. That tells you about 5-point summary. At any point, is it giving me the data type?
no.
So yesterday, someone was saying. So now you got the answer.
Yes.
Yes.
Okay. Chalo, thoda sa in our in our analysis at the very first phase, before we apply the model, we also do some visualization. Yes, no.
Correct.
So let's do some visualization, right? So import is done, right? Import is done. Now, in order to do which plot I should use? Let us use, see here, need not to go through each of the variable, right? Because there is no null, as I can see, correct? No null. So all those things. So what I'll do is I'll directly plot what the pair plot. You know pair plot? Let me show you. So Seaborn as SNS. So SNS dot pair plot. And then what is the name? So advertising. Okay. What else? Now we have to give X wheres and Y wheres, right? Wheres, right? Okay. And kind is equal to, I'm just giving scatter, right? Scatter plot. Now what is my X variables?
TV.
TV.
TV radio.
So I need to pass a list. Okay, I need to pass a list. Okay, so it is TV, correct? What else?
TV,
I
radio.
hate it. After I write na, whenever I have to press the right arrow just to come out of the inverted comma, I hate it. Okay, what is the third one?
Newspaper.
Newspaper, right? So these are my 3 variables. Now I want to see with respect to what is my target variable?
Sales.
Sales.
Right? And since it is only one, so what I'll do is sales. Okay. Kind is equal to scatter. Okay. Let's go ahead and see. यार इसका size थोड़ा बढ़ा सकते हैं क्या? Just let me see. Size is equal to कितना करते हैं? Let's say let's do some 5. Okay. Okay, so the Y variable is sales and X is TV, radio, newspaper respectively. Okay, makes sense?
Yeah.
Yes.
tell me, by looking at the scatter plot, which variable do you think is better?
TV.
TV
TV
looks
TV.
more.
is slightly better as radio.
More what? More what? What is that particular term?
It's strongly correlated with.
Strongly correlated. Yes. Yes. Achha, 1 second here. We did not. Okay. Okay. So this is also, you can see that this is a correlation visualization kind of thing, or scatter plot usually used in that way. Which variable do you think is not so related with sales?
Newspaper.
Correct. So these, whatever you are telling me, whatever you are telling me, these are analysis, right? Analysis of what? Target variable with respect to
Predictors.
Or independent variable. Okay. So whatever you guys are telling me, those are analysis. Okay. Those are analysis. So your analysis can come through any of the this thing, statistical this advertising.describe, I mean 5-point summary. It can come through any of the plots, right? Or whatever you want to do with the data in all the things that we have studied, it can come through any of the things before going for the prediction or before applying the machine learning. Okay, it can come from the correlation also. That is what we are going to see next. Okay,
Yes.
tell me which particular plot we use for correlation.
Heat map, right? Heat map.
Yeah. So we'll use heat map. So SNS dot heat map. This is one map you will use in all of the problems, right? Mostly. Okay. So you have to see heat map, and what we have to see? We have to see the correlation. So advertising dot correlation core. Okay. Okay. And okay. Annotation. So annotation we have to give true. That's all, right? So what happened? Why is it? This is the problem, you understand? So let me see, why is it happening? Arey yaar, I'm not liking it. Acha. Let's see. Sometimes it works fine. Are you able to see what is the problem here?
The first row and the last row
is not properly visible. Okay, so let us see. C map may
Red.
Oh, there is one code. I'm failing to recall. Why? Because we have to show it to the client, right? So I somehow remember. Okay. No, it's not taking. Acha, okay. This is. Now it is visible, right? थोड़ा सा visible हुआ है. Correct?
Yeah.
Okay. Not going into the detail of
Subplots to increase the size.
Huh?
Using subplots, can we increase the working area?
So you are saying size. So size, let's say 5. ठीक है. अरे यार size है ही नहीं क्या इसमें?
PLT dot subplots. and then fig size we give to increase the working area in the beginning.
ठीक है, for now
That is done.
do this as your own task. Okay, for now the purpose is not to teach you visualization. Okay, purpose is to do the analysis. Okay, now you are able to see. Okay, so diagonally it should be 1 and it is showing as 1. Okay, and except that we are able to see what is the relationship with respect to all the other variables. Yes or no? Correct?
Yes, yes.
Okay. What are the takeaways from this particular heat map?
TV and sales
TV
are
and sales are
strongly correlated.
Strongly correlated, right? Then comes the radio, then comes the newspaper. And that was actually visible from our scatter plot also.
Plot itself.
Right? Yes or no?
Yes.
Now if I have to let's say do the same thing, do the you can say the regression, can I only use one? If I have to use only one variable, which one I will use? Which one I should use?
TV.
TV. If I have to use two variables, which one I should use?
TV and radio.
And if I have to use three variables, then obviously you can tell TV, radio, newspaper, right? Correct?
Yes.
So let's start from the very basic, right? Let's start from what? X and Y. So instead of going ahead and dividing the whole data, let's say I'm just defining X and Y as, let's say X is equal to what? Let's start from, okay, advertising, and then I'm selecting one column. Which one should I choose? TV. Why? Because it is highly correlated with target variables. Okay, and Y is not no brainer. So this is nothing but sales. Understood? So instead of TV, it is sales.
Yes.
Okay, so I have defined X and defined Y. Okay, so create it. What is the next thing I'll do? What is the next thing I'll do?
Create three.
Splitting. To train and test. Tell me, which split ratio should I choose?
80-20.
Whatever you will say, I'll choose. Okay.
80-20.
80-20. So split ratio 80-20. Okay. Now, what is the thing that we have to use? From sklearn, right? Dot model selection. If you remember, I told. See, no need to remember this, but the more you will use it, it will be on the tip of your tongue. The way it has become on the tip of my tongue, right? So train, test,
split.
Okay, now it came. Okay. Now there are 4 splits. If you remember, what was those 4?
X train,
Y train, Y test.
Okay. So train underscore test underscore split, right? And then I'll pass X because I've already defined Y. What else? Training size.
Yeah.
What is that? 80%. That is 0.8. If it was 75%, 75-25, then training size was 0.75. Correct? See, if you specify train size, you need not to specify test size. But since it is starting, I'm just writing both. Okay. So train underscore size sorry, test underscore size is what? 0.2. Okay. And there is one thing called random state. Let's choose it as anything. Let's choose it as what? My birthday. Okay. Clear? Why? What is random state? Anyone can tell me what is random state? See, this is a key given to the split. So I said, since it happens, you can say differently. So every time you do, you won't be able to reproduce your result, right? Okay, let me use the annotation here. I will explain. It will have a huge confusion regarding this also, but this is very simple. If you remember, in our example, what I did, I used 80-20 or 70-30 split. At the time I was explaining, yes or no?
Yes.
70 for train and 30 for test.
Yes. Correct.
Since we are taking 80-20, let me explain using 80-20. So let's say 80 for train, 20 for test. But do you think actually that top 80% will be used for training and last 20% will be used for testing?
No.
No, it is chosen randomly. That means 80% from overall data, 20% from overall data, randomly, right? But that randomness, every time it will change. Yes, no.
Yes.
So you yourself won't be able to reproduce your own result. For that, if you make a random state as any value, you give any key, you can give anything. 89,000 also you can write. So that, and if you use the same number, the split will happen in the same way, so that you are able to reproduce your results. Clear? Bolo yes, no.
Yes, understood.
Okay. Now what to do? Run it. अब क्या हुआ यार?
Test and
size.
अच्छा, SIE हो गया क्या? Okay. ठीक है, done. Now I am done. Okay. Now what we have to do? Let's see once X train and Y train. Okay. So X train, let's see what is it. So how many columns we had in total?
4.
200. What is the 80% of 200? 80% of 200.
160.
So see here. What is the length of X train? 160. That means our split is happened properly, right? Let's see X test also, right? So X test. Okay. X test. $40, right?
Yes.
Okay. So I just shown. Okay. So okay, let's say how many. If I use dot head, how many values it shows?
5, top 5.
Top 5, correct? And if you see the random, how it happened randomly, that our serial number, how the split has happened into train test, you understand? The 23rd came in test, 62, 159, 73, like that. And here it is 119, 77, 148. Clear?
Yes.
Like this. Okay. So this I'm talking about. So this is what has happened. That means now you can also understand that it happened randomly. Okay?
Yeah.
Yes.
Clear? Now let's say, okay, all these things are done. Similarly, you can see Y train, Y test also. Okay, because 4 splits has been done. Okay. Now, see, in all the times in the production, you would be using sklearn to build all the models. Okay. But here, since it is our it is our starting. So let's say we are starting with stats model. Okay. Understood? So what we can do, we will be using stats model. So let's import stats model. अच्छा यार यहीं पे कर लेते ना import import stats sm. Okay. What else? ठीक है, stats model तो हो गया. नीचे हमने already we have done what we have already done sklearn, right? So sklearn we need not to do, correct?
Yes.
Yes.
ठीक है. So let's go ahead and do some using stats model. Okay. So we have to do what? Linear regression. So as I said, first of all, what we will do? We'll import. Now, now what we will do? We will add a constant to get an intercept.
Yes.
We need to have a constant, right? So let's say I'm just adding, so x train, right? And let's say stats model, instead of that I'm using sm. So what I'm doing is using my stats model, which I have imported alias as sm. So sm dot, there is something called add constant, right? So add constant in what? X string, right? X string. Okay. Because we have to implement which particular equation? Y is equal to mx plus c, correct?
Yes.
So x is there, okay, c was not there, so we need to have a constant, right? If we want to, let's say, get an intercept. Yes or no?
Yes, yes.
Now what is the model name I said, which we are going to use? Ordinary least square, right? So let me name it as, okay, so let me label it. इसको क्या बोले यार? Adding a constant to get what? To get intercept, an intercept, right? Intercept. ठीक है? तो let me leave it here as it is. ये क्या हो गया? Oh, अच्छा ठीक है. For now, let me import. I did not run it again, correct? Before using it. So let me, I don't want to run everything. So let me quickly import it here. And then run it, right? So run it. Now it is done. Okay. What was the error? You understood why it happened? All of you?
Yes.
Yes.
Because I wrote the code but did not execute it, because I wrote at in the first code box. Okay. Now what I'm doing is I'm fitting the regression model using what? OLS, ordinary least square of stats model. This is for your reference I'm writing. Okay. So let me name it linear regression. Okay. And let me write SM, which is our module which we have imported, stats model dot OLS. Okay. OLS. Right. Now what is there? Y train. Okay. And then, sorry, what is my constant? X train SM, right? And then what I'll do? I'll fit. We always fit the model, right, onto what data I'm just passing it. Yes, no?
Yes.
Okay, let me first name this. So this is our linear regression practice. Okay. Got it? Now let me fit it. So first what I'll do is I'll fit it, and after that what I'll see the parameters which we have got. So I have assigned it to LR, which is short form of linear regression. So if I have to see the parameters, so I can just see LR.params. What it will give is, if you see there are two values, right? So if you see there are two values, what are those? One is
Constant.
intercept and one is slope. Correct? So constant, if you see, is your intercept, and the name against the variable which you have passed. So for now we have only passed which variable?
TV.
TV. So the slope should be against, or slope or weight, anything you can say, is against the name of your variable. Correct? You understand? So if you will use multiple variable, which we will see next, okay, then the constant will be 1, but your slope will be multiple. And that is the reason precisely because the slope is written against the variable. Let's say tomorrow you will use two more variables, newspaper and what was another, radio, right? So constant will be 1, but your slope will be 3. Yes or no?
Yes.
Yes.
So what I mean to say is your y for multiple linear regression was beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3, right? So this is one, but this is one slope, this is another slope, this is third slope. So these three will be coming against x1, x2 and x3. That will denote that this slope is, sorry, अच्छा इसमें होता नहीं यार, undo यहाँ से. Okay, so this slope is for TV, right? That means if I have to write, so I can write sales is equal to 6.894375 plus 0.48660 into TV. Whatever the value of TV you will give me, okay, or advertisement of the TV, any value it will come, yes or no?
Yes.
Then that will give me the sales, right? Only through TV, okay? Understood? Let's say tomorrow the sales, I just want it to be the variable of TV plus radio plus something. So this will change, this will also change, and another. So let's say this will change to, I'm just taking an example, 5.86 plus 0.34 into TV plus 0.42 into newspaper plus 0.32 instead of what, radio. This is what will happen. So intercept is 1, but there will be as many slopes as you will have the variables in your data. Understood? And that is the reason you are seeing the variable against the, sorry, you are seeing the slope against the variable name. Cool? Got it?
Yes.
Yes.
Okay. There is one more thing. And since we are using stats model, so it will be showing statistically so many things. All of it is not of our use, okay? But only we will try to read what is of our use. This will give you the summary of the model that we did, since that was a simple linear regression using one variable, okay? Similarly, as I said, even this will be same for multiple variable, okay? I'll show you. So if you see, it tells that what is my dependent variable? Sales. Which is the model I have used? Ordinary least square. What is R square? This much. What is adjusted R square? This much. That means my 63.5% is my R square value, right? Method is equal to least square. All these things, F stat, date, probability, all those things will be given. No need to go through all these, skewness, kurtosis, Durbin, Watson. There are multiple statistical technique given which is not required. Those are for the people. See, stats model is used by statisticians. Okay, but since we have studied stats also, so I just wanted to show you using stats. Obviously, we will use sklearn also. Okay, clear? Number of observation 160 because we are training the model. Yes or no? Correct? Correct. DF of residual 158, DF of model 1, all these things. Okay. So our purpose is solved when we see R squared, adjusted R square, right? And what is the dependent variable? Anyways, we know this, right? So these two things, if we get from summary, then that is fine. Clear? Can we go ahead now?
Yes.
What else can be done? What else can be done? Tell me.
We are going to run this.
Acha, one more thing. See here, if you haven't, if let's say if I don't type, if I don't get the parameters from here, right? So alternatively, what I can do is I can see here. So if you see, this is the coefficient, right? Right? And this is the slope. Slope with respect to the variable. Since we have only one variable, even though this was not written, we would have got to know that this is for TV. But why is it written is because tomorrow you may have multiple variables. Then it would be hard to interpret. Okay. So this is, and with respect to this, what is the standard error it is given? Understood?
Yes. Yes.
Now see, if you see the p-value is 0, right? Now if p-value, right, is low, very low, right, almost 0 or around 0, then you can say that the coefficient or anything for that matter is statistically significant. That is how we have studied in hypothesis testing.
Yes, right.
And that is where you will perceive this particular thing. Okay. Understood?
Yes.
Yes.
Okay. What do you perceive by R square value as 0.635?
Variability of TV with respect to sales.
Variability with respect of TV with respect to sales is what you say. Yes, you are correct in a way, but the better way of telling this is that 63.5% of my dependent variable or my sales variance can be explained by my independent variable. In this case, that is TV. Clear?
Yes.
Yes.
Okay. Now, one more thing that we see from this is F stat. If you see, probability of F stat is very low, has a very low p-value, right? P-value. Correct? Now, see, this is F stat and this is probability of F stat. That means p-value of F stat. And this is very low, correct? E minus 36 means 10 raised to 1.87 into 10 raised to power minus 36. Now you can assume how it is practically 0. Again, that tells that whatever model that we are using statistically significant. Correct? That means it is a good to go model, right? Though if I may be happy with the R square value or not, but F stat is telling me that this is statistically significant. Understood?
Yes.
Yes, no, maybe. So I'm just trying to give you as much as you need to know, okay, as a data scientist, okay. All these things we know, right? How to interpret the probability and how to relate it with statistical significance, correct?
Yes.
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 Okay. Now what we will do is
I'm saying
since we have
one doubt, bro. See, in this when we did this analysis, right, we never did and found out whether this is normally distributed. Shouldn't we do that? Or we assume
whether
that
it
it
is
is
normally distributed. See, I tell you something. Okay, whenever you get the data, right? Whenever you get the data, 99% of the time you consume it as it is, only because you assume that it is a sample, right? It is a sample, and it is a sample of a of an another normally distributed uh, uh, larger population, right? Sample is of population. Now you have to think it. Yes, if we go through the exact rule, bookish rule, we should have done that, right? But no one does that, okay? Because stats or machine learning works on assumption. Half of the time, whatever you have studied, you won't be using it, because those are ideal conditions. But it is good that you know that whatever we are dealing is should be normally distributed, okay. But then again, I'm saying if it is around normally distributed also, then also you will be working on with the data, okay. Clear? You got it?
there can be a chance where this assumption is wrong, right? Where it
Huh?
may not be normally distributed, but we are assuming that it is normally distributed. There could be a
So it
chance of
is not, see, there is whenever you get a data, it is not 100% normally distributed, any data, right? You understand? So there is always a chance of an error. Whether that error is more or less depends upon whether it is highly it is highly a constant distribution or exponential distribution, those kind of distribution, right? If that is the case, then the chances of error is more. Otherwise, most of the time we are good, okay, correct. But yes, you are right. Whenever we are working in a project, and if you are working on anything, right, obviously you can plot the distribution and you can see if it is normally distributed. Obviously, see, multiple things we did not do here. Did we do the pre-processing? Like, did we see the outliers and all? No, I did not do. But does that mean that you also won't do, or you don't know that? You can do that, right?
Yeah, we can.
Correct? Because I know that there are no outliers in this data, right? But if there are outliers, I have already told you, you also have given the assignment how to remove the outlier, right? Once you have removed the outlier, you can use that. If you know, if the data is not normally distributed, then what you have to do? Correct? What happened?
if it is not normally distributed, what do we do? I just missed that part.
Sorry?
If it is not normally distributed, what should we do?
You tell me, what should we do? There is a whole class I took for that.
Z score.
Not the Z score.
Z score works on normal distribution, right?
Not the Z score.
We find if the data is skewed or why it is
No,
skewed. Does it have an outlier?
that is one of the things, yes. But what is the central idea?
Because if the data is large, if the sample is large, based on central limit theorem, it will
Yes,
always
yes.
come to a normal
So you
distribution.
will apply central limit theorem, sampling distribution of the sample mean, right?
Yeah.
Then you have to take multiple samples from the population, correct?
Yes.
And then take the mean, and then that will be normally distributed. Central limit theorem. This question will be asked for sure. So third attempt में नहीं, first attempt में this thing should be in your mind when speaking. I know it is things have so much things we have all studied, but these things are important. I told you, whenever we are learning an important thing, why is it important? Can anyone tell me why central limit theorem is so important?
Because it helps us
You can apply the statistical
Everything that we have
formulas
found is based
on
on
the
normal
Because
distribution.
it helps us in generalization. The question someone asked was very valid question. If it is not normally distributed, but the answer should also come from you guys only, right? अरे machine learning में आने का मतलब थोड़े है कि you will forget everything what we studied in stats. थोड़ा revise कर लो, right? I have written everything by my hands. तो उसी को पढ़ लो ना. If you haven't written the important thing marked as important. Not asking you to go and watch 3 and 4 hours video every day. You can just go through my class notes. Correct?
Yes.
Please go through it. Okay?
Yes.
Chalo. This actually is not actually fine. Okay, I'm not fine with it. Okay, now let's see what visualize the regression line. What is a regression line? What is a regression line?
best fit line.
Yes, best fit line. Right? So I told you there are infinite lines that you can imagine going through that space, right? But you have to choose the best fit line. Which will be the best fit line?
Which has the least error.
Minimum error, right? See, but that is our conceptual, that is an ideal scenario. But let's say, how will we come to know that this is the minimum error? We have to iterate, right? We have to iterate. Yesterday we were doing that, right? Cost function, we were iterating and it was reducing. Let's say if in 1 hour I am not able to find what is the best fit, my error is further reducing, and I have to present it to my client. What will I do? I'll stop there. I'll assume that that is the best fit line. Correct? So ideally it is best fit line, but it also depend upon your complexity, time complexity, your space complexity. You don't want to find out the best fit in 3 days. Okay. So in that case, what you can do is you can assume whatever error you are fine with it. You can take it as a minimum error, or you can say that this is the error, I want to live with it, and tell me the best fit line with this error. Okay. So they will live. Okay. So let's say PLT dot scatter. अरे मैंने did I import matplotlib on top? Remember?
Yes.
Yes.
Yeah.
Okay. ठीक है. So PLT dot scatter, and first of all, what we have to do? X train. So we have only train, right? So X train and Y train. Correct. So X train, Y train. What else? Now again PLT dot scatter. Yeah. PLT. No, sorry. So we can simply plot, not scatter, but we have to plot the line, right? Now what we can do is we can use X train, right? And X train. Along with that, I can directly interpret the line. How I can do that? I know the intercept. What is the intercept? 6.8944, right? So I can write 6.8944, right? Plus what? What is the slope?
0.0487.
487, right? Into what? X train. Yes, no?
Yes.
Because my X train only contains TV, right?
Correct.
Let's say it's taking hour, okay, and let's do PLT dot show. Sometimes even if we don't write PLT dot show, it shows, but let's not take chances. Let's see. Okay, this is our best fit line. Correct. Size बढ़ा दें थोड़ा सा. Size equal to 5. Yeah, it doesn't take size. Oh, let it be. Are you able to see it?
Yes.
Yes.
Correct. So that is nothing but a regression line or best fit line, popularly known as best fit line. Okay. So this is the best fit line. We have got the slope, we have got the intercept. Let's do some error analysis. Error analysis, yes, no?
Yeah.
Okay. So let's predict. Okay, so training data. Okay, so what we can do is we can name it as y train PRET is equal to, and then we can use LR dot predict, right? And what we can pass? We can pass
Extreme.
not extreme. This is our what? If you remember correctly, this is our constant, right? Right? So this is our constant. So let's say this is what we have predicted. Okay, so this is our prediction. Okay, what we have to do now, if I have to find out the error, we have to find the residuals. And how will we find the residual? Y train minus, sorry,
Ready.
right? Correct. Y minus Y predicted is what was. So if it is a training, data that we are looking to find the error for, we will write Y train minus Y train pred. If it is testing data, then Y test minus Y test pred. Clear? Right?
Yes.
It's done. Okay, it's done. But see, if I just if I just show you the error, you won't be getting anything. So what we can do? What is the best way to show the error? What is the best way to show the error? Note it down. The best way to show the error, right, is to plot a histogram. Distribution or the distribution of error, right? Distribution of error, how the error looks like, right? Okay. Now let me right. Now let's use Seaborn. So SNS dot distribution this plot. Correct. What should be right? What is the name of our error?
RES.
RES.
And let me use here 150 and 160. Training data is 160, right?
Yes.
So around okay. So let me use 15. Okay, 15 means okay. Okay, and okay. This is how it looks. Correct. The distribution. There are few things that you can change it for, right? Like plt dot title. Obviously, see, you should always write this. Okay, error terms and okay. So that is plt dot title. Then you can write plt dot x label, plt dot y label, all those things, right? So plt dot y label. So plt dot y label. What should be the x label? What is in x?
Residual errors.
Right. So it is nothing but residual errors. Correct. Or you can also write that is nothing but, you all know, right? Y minus y pred. Correct. Similarly, what should be the y label?
Frequency.
Frequency. Right. Okay. Okay. What else? Anything else you think should be we should write? So yes, this is how it looks, and this is a distribution of your error, right? Residual error. Clear? Tell me, is it following a normal distribution?
Yeah.
Yes.
Yes, it is almost normal because you see the mean is 0 in between, right? Right? There is some hiccup, but this is very, very normal distribution. Okay. Okay, what else? Now comes the most important part. So till now, can someone sum up what all we have done? Anyone?
Yeah, evaluation of matrices like error matrices, mean squared. Means you are talking from beginning, right? What we taught today?
Beginning. So see, we have splitted the data. Pre-processing, I'm not talking. We have splitted the data into train and test by the ratio
80-20.
what was the 80-20, right?
80-20.
Yeah, 80-20. Now the train is 80, rest is 20, test is 20, right? Now you have to understand, I haven't touched test yet. Whatever I have done, I am working with train, right? So I have predicted using my linear regression. I have predicted for train, right? So I have called it y train pred or prediction, and my actual, right, something like that. So y train pred and x train, right? And now, sorry, y train. Now this is my actual and this is my predicted. Correct? And that is the reason subtraction of this was giving me the error. What is this error? This error and the r square or adjusted r square, whatever we have seen, is your training accuracy or training error. We haven't touched test yet. Test data, that is 20%. Our model will be said to have good generalization only when your training data and test data is comparable. Okay. What happened? Someone is sleeping or what? इतना बोरिंग है क्या यार? So what now we have to do? We have to go and do the same thing for testing. Correct?
Yes.
Everyone on it. Please do
Yes.
not
Yes.
lose track. Okay, that is the reason I'm not taking a break. I know it's break time. I'll rather finish it and then take a break than to keep you hanging in between. Okay, I'll leave it like yesterday. I won't delay. Okay, now what we will do? We will do the predictions. Let's quickly do the same thing. Now we are repeating the things. So we won't we won't explain each and every step. So what we will do, adding constant, and now it is in test data. So what we will write? X test SM. We will use the same naming convention. So SM dot add underscore constant. Right? And then what I'll do? X test. Correct? What else? Now I'll predict the value. What I'll do? I'll predict the value. Because see, now I need not to train my model. My model is already trained, right? So do I need to fit again?
No.
I can only I can predict, correct? Because I have already trained my model. Okay, this is the pre-board which I am taking of my child. Okay, so y underscore test underscore pred or prediction, right, is nothing but linear regression. Why I'm writing LR? Linear regression, it's not generalized linear regression. Why? Because I have named it LR. If you see, I have named, after I have fitted my model, I have named the model LR, and that is the reason I'm using that instance of it. If I would have given L underscore R, I would have used the same name. It is not that it is short form of LR that we are using. Okay. So what should I write? LR dot?
X underscore test.
Array nahi, but what should I write? LR dot. What I'm doing? I'm predicting, right?
SM.
So it is very, very easy. Since you are predicting, you have to write predict. Correct? So let me quickly comment. So what I have to predict?
X underscore test underscore SM.
Right? So that means if I run it, now my prediction for X test is already, come in here. Where? Y test prediction, Y test spread. Okay. Now again, if I have to find the residuals or error, how will I do? How will I do? Using the same formula. Only I have to do what?
Y test. Y
okay.
test minus Y.
Y test and Y test predict.
Y test spread. Okay. So before that, so you can calculate, right? That you can calculate.
Yes.
Okay. So residual you can calculate. You have to just simply use this. Okay. Instead of Y train, let's do this, right? Okay. Only I won't plot it. You can plot at your own. Concept is important. Y test, and let me name it this. Okay. Okay, done. Now instead of okay, ये भी कर ही देता हूँ यार. Instead of res, you will see res dot underscore test. Okay, error terms. So you can just write test error terms, test data error terms, something like that. Okay, you got it. Okay, is it still normally distributed?
Yes.
Yes, it is. Yes, it is. Okay. I mean, approximately normal, but we will still tell it as normal distributed. Okay. Now, most important part. Now we have seen using stats model. We are on top. We have seen R square or R square. Let's say if I have to find out R square. Okay, I can do it using sklearn also. So sklearn dot. Now this is matrices. Sorry, matrix import R2 underscore score, right? So R square they don't write, R2 score. Okay. Now how to check? So R squared value, I'll put it as R2 underscore. Hey guys, this is really okay. Just give me a moment.
Dhruv, please mute him.
I'm not sure who he is. Okay. I muted everyone. Please unmute only if you have to speak anything. Okay. R square, and then how will I find out the R square of my test data?
it is.
Yes or no? And then I'll just try to print this. So this is my R square of my test data. Do you think the model was generalized enough? Because my test R square is less than my training R square. That means I need to see what is the fault that I have done. Correct?
Yes.
I'm not happy with the model. My model is not generalized properly. So maybe I'll go ahead and change the ratio. Let's say if I want to do 70-30, something like that. Clear? 70-30, 75-25, all those things. And then this is the point where you will use your pre-processing technique. Okay, pre-processing technique. Clear? So let me do one thing. In my previous class, I'm not sure how much I did. Okay, so let's what should be the another ratio that you want to try?
70-30.
Hmm?
70-30.
70-30.
Everyone agrees on this?
Yes.
Okay. Just give one moment. Hmm. 70-30 means 0.7 and 0.3. Let's see if the things are going fine or not after this. Okay, visualization. Okay, the R square has increased from the previous time, right? 0.64 it becomes. Okay. Now let's see if my things, it won't be a drastic change, but let's see. Correct? 0.51. Okay, it has increased or decreased?
Increased.
Last time, what was it?
0.49.
49 or something, right? So yes, you see, you have to do trial and error multiple times. Okay, then you see, okay, currently we have only one variable, let's say. Later part, we can see that we can add 2 variable, 3 variable, and then what, let's see what is the training score. Maybe it is not able to generalize properly. Okay. So R square I'm just giving you the tools. How do you need to know? Okay. So R square we have got. Now again, you can we haven't plotted the regression line for the test data. You can also do that. So I'm putting it as a comment. So you can plot a regression line for test data. Okay, you can do that. I'm just leaving it for you. Yes, no, bolo.
Sure,
Yes.
you can.
Okay.
Yes.
Now coming on to our method 2. Okay, so let's go ahead and use method 2. Method 2 means I'll now use sklearn, right? Sklearn. Again, sklearn train test split is done, already done, correct?
Yes.
Yes.
We have done the train test split using sklearn, right?
Yes.
What we can do is see the very easy it is from sklearn, right? Dot linear underscore model, right? Import linear regression. So linear camel case regression. Okay, sklearn dot linear underscore model import linear regression, right? And what we will do, we'll create the object, that means instantiate the linear regression. There I named it, let's say LR. Here I'm naming it LM, linear model. It's up to you what you want to name. Okay, so I'll just instantiate the way we do with any other sklearn module. So linear regression, like, right, we will instantiate it, and then as simple as that, what we will do, we will just pass lm.fit to what, x train, right? Just give me one moment. Okay, I think we need to Okay, see, before I do this, since we have used the same the same split in our stats model, so what I'm going to do is I'll make another split there. Okay, just give me a minute. So let's use this. Okay, the same one, but we'll rename it. Okay, train test split. So just let me name it X train LM. Okay, X test LM, right? Y train LM and Y test LM. Okay, and now everything should be same. Okay, need not to worry. Okay, everything should be same, need not worry. Okay, okay, one more thing. Why I did so? Because if you remember, we added constant there, which we need not to do here, right? Instead of that, right? Okay, how do you add column to any data frame?
Data frame of that column name.
No, that is one thing. Another one is additional column using reshape. Any of you know what is the use of reshape?
Yeah, extending rows and columns.
Correct. So I'll use that one. So X train LM and what? X test LM. Okay. So in both, what I'll do is I'll X train LM dot values dot reshape. Reshape in which way? Any confusion? Correct. Now let me show you something. Okay, kahan tak the yaar? Okay, just give me 1 second. Before this, okay, leave it. Okay, so this I have said. Let me run from here. Okay, this is done. Okay, let's see here. Okay, now what we are going to do is, now we are fitting it. Now we are fitting the model. Fitting which model? Linear regression model. It is very simple. So what we have done is we have instantiated a model and then we are fitting into our newly built split. See, I would have kept it X-train here, but we have already inserted few things there. That is the reason I had to change the name. Otherwise, you would have used the same. So here it is Y trained LM. Okay, the way we have named it. Okay, so this is fitting the model. So can I run it? Yes. So it is done. It has fitted. Now what will happen? Done. It's done. Nothing else. So what you can do? You can simply print what? Slope and intercept. How you can print?
lm.params.
Not here lm.params. That was stats model. Here you have the name intercept underscore. Okay, so this is your intercept. Okay, correct. Similarly, if you have to print the slope, right? So you will slope is nothing but coefficient, right? So coefs, coef. Okay, I think it is only once. So it is giving you the slope and this is giving you the intercept. This is how you can perceive it, right? How you can perceive it, that this is what it is giving. Okay. Yes, no. How will you use, okay, how will you use sklearn to make predictions for y? So what you can do is y train pred is equal to lm dot predict. We have only fitted the model, right? We have to predict. So in order to predict, what will I pass? For training, we will pass training x, and for what? Test, we will pass the testing data. Yes or no?
Yes.
X underscore test underscore lm, right? Lm. Clear? And now so let me do this. Once we have done that, after this, let's say if you want to print, okay, before, okay, so and what will you pass? For training, what two values you will pass? For training score, what you will pass?
Test and X test pred.
Correct? So y train you will pass,
Y
train pred you will pass, and similarly for r square of
Y train lm.
Y train lm and y
train
pred, right? This you will pass, okay? And similarly, so this should give you the score, training score, right? And similarly, instead, if you have to find out the test accuracy, all of you understood what is difference between training and test accuracy, and why do we need to find out twice?
Yes.
Comparing to models.
Sorry?
To compare.
Whether the model we have trained is good with the test data.
Whether the model we have trained is good with the
test data also.
Test data also. Okay. What else? So see, as I told, you can think of trained data. You are correct. All of you who gave the answer are correct. So let me reiterate, the train is nothing but while training, whatever test you take, that is unit test. You can think it like that. And testing accuracy or testing R square, testing error, whatever you calculate at the time of testing is nothing but your pre-board. Then you will ask me, then what is board? Once you deploy the model, okay, see, test is also a part of your data only, correct?
Correct.
Yes, no?
Yes.
But you are building model to predict something which you don't have. You are building model for that purpose only, right? So for that reason, what can happen is you can deploy your model and your model will perform prediction on any unknown data in future if it will come. That means I'm saying that if you give any value of TV, radio, and newspaper, it will give you the sales. Correct? So that is your board. So what is your unit test? Your unit test is your training score. What is your pre-board? Your pre-board is your test score. And what is your boards? Boards is when you deploy the model and your model performs on unseen data or any future data. Any confusion till here?
No.
Okay. So that is basically the two ways in which you can do the modeling, regression model, right? Now, where do you invest most of the time? The investment in your time will happen throughout whatever we have discussed, right? Cleaning the data, imputing missing values, right? Seeing the variable. Currently, we have 3 variables, right? Tomorrow, we may have 30, right? Then you have to work out on variables, right? You have to choose right variable. You have to impute missing values, right? All those things takes time. Training the model, scoring doesn't take time. Understood my point?
Yes.
Any confusion till here?
No.
No.
Okay, if you don't have any confusion, then here is my assignment. Since this is a long weekend, I'm just giving the assignment as, first of all, adjusted R square I want to calculate. Okay, I want to calculate adjusted R square for each of the value. After that, currently what I am doing, I have used only TV. I've used only TV. Acha, let me use last batches. Okay. This time, what I have done is, I have done from starting to finish in a way that it, okay. So see, you can make a variable called feature columns in which, in which you can pass one variable. Later what you can do is, you can pass 3 variables, 2 variables, like that. So your assignment is that based on adjusted R square, one by one, you will put the variable. Let's say currently I'm using TV. Next time I'm using TV plus radio. And what I'm doing is I'm finding out R square and adjusted R square. And after that, what I'm doing is I am telling myself that since both are increasing, that means the added variable is good. Understanding this point? If my R square is increasing, but adjusted R square is decreasing, then I'll write the conclusion that the added variable is
It's not good.
not good. Good is not the sentence. What was the right word that I used?
Not.
The right word is there in our handout. Okay. So if you see, the right word is
True. Are you going to share data set?
I'll share the data set. No need to worry. I'll share the data set. I'll share the code playground. I mean, whatever we have just today did. Okay. Insignificant is the right word. Okay. Not good is not the right word, but insignificant is the right word. Okay. I'll upload this also handout. Okay.
Sure.
This time, your batch only, I have done this hands-on. Okay. Otherwise, what I used to do is, since gradient descent is something which was using our own concept or own formula, I was using it. And for all previous batch, I was just taking them through already coded this. Okay. It was taking less time, but I think we did more. Okay. So I'm just giving this. Okay. I think data is not the name, but what is the advertising is the name, right? Advertising. So see, you need to check right now. See, you have got what coefficient. What if I have to know the what slope? Sorry, slope is coefficient. Constant if I have to know. What is the right?
Intercept.
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 Yes.
Intercept.
Right. Okay, and like me, don't put COE and then underscore. These things you will keep on practicing and then you will get to know. Okay, so this is how multiple regression work. What changed? Nothing. Instead of 1, I am passing 3. I can pass 2 also. So if I change it to 2, and let it be. Okay, you can change it, and then you got the assignment, right?
Yes.
So basically, you have to work in a way that you should be able to understand which variable is important, which is not. Okay. So let me write
Yes.
the assignment and then we will break for, I mean, I'll not break, but today's class will finish. So the first is to see adjusted R square, and the second is so one place. That means, see, I want, if you have trained your model, after training your model, I want R square, adjusted R square, right? MAE, let's say on at least one error matrix, these three. Okay, understood? No need to, if no need to code for RMSE, you can use sklearn's module. Just Google it, RMSE in sklearn, that's all. Okay, why I'm giving you this is, by that way you will go and read the documentation. See, once you will type now, there will you will get the link from n number of blogs which will directly use it. I will not suggest you to go there, rather I'll suggest you to use the documentation from sklearn. If you start reading the documentation, it is going to help you in longer run. Clear?
Yeah. Yes.
Okay, I'm happy that you guys sent me the assignment which I gave few of you, right? And yeah, you are on the correct path. Okay, chalo, with that, any questions? Any questions?
Not yet.
Okay, then I have questions. Wait, only 5 minutes. You have got what is linear regression? Yes, no, to bol do kam se kam. I'm not going to ask.
Yes.
Yes.
Linear regression you should be able to understand. Okay, what is independent and dependent variable?
Yes, understood.
Right.
Okay, what is best fit line?
Correct.
Got it.
What is gradient descent and how does it work?
Yes.
Yes.
Yes,
With coding part also, right? What else? Then your
Matrices.
evaluation matrix, regressions evaluation matrix, R square, adjusted R square, right? What else? MAE,
RMSE.
Yes, matrices.
MAE.
MSE, right? Okay. What else? अच्छा इसके नीचे लिखना है क्या? What else? Multi-collinearity, right? And how to avoid VIF, all those things, right? Heat map, right? Correlation. Okay, we have gone in depth. I'm not telling that again, but we have gone in depth of what R square value, right? How R square, and we have related it with our previous understanding of variance, covariance, correlation, and then regression. Okay, and this is coefficient of determination or regression coefficient. Clear?
Yes.
Would you be able to answer any questions if asked from this?
Yes.
अरे
Yes.
confidence ही
Yes.
नहीं है. How will
Yes,
you
yes.
crack it? Okay. Okay, with that, okay, how to fit the model? How to fit the model? Dot fit used to
Yes.
fit the model. When I'm using dot fit, what actually happening in behind?
It is training.
Yes, training means my model is learning. it is keeping the nodes, making mind map, right? All those things. Understood? So it is learning a plus b whole square is a square plus 2ab plus b square. Okay, you are telling 6 plus 8 is 14, then it is learning the rules, right? You understand what I'm saying?
Yes.
Yes.
Dot predict, what it is giving, what it is doing. If I'm doing dot predict,
Predicting the model.
Test.
not test, predicting.
Predicting. Yeah.
Test, what is test? Test is nothing. Test is just the name of the data set which you have kept aside to test your model. Okay, so dot predict will, if you pass a data set, it will predict the value using whatever you have passed. Understood?
Yes.
Yes.
Okay. And how will you evaluate your model? Based on all these parameters, correct?
Okay.
And what are the two techniques we have seen? Stats model, sklearn.
And SQL.
No need to use a stats model, you can always use sklearn. Clear?
Okay.
Yes.
Okay. ठीक है, चलो. So from next class we'll be starting another. So we'll be starting logistic regression. Okay. So do the assignments which I have said. Okay. And you can again, no need to send me .ipynb on my WhatsApp. That is of no use. How will I open that in my phone? Okay. So you can just take the screenshot and send me instead on WhatsApp. Clear?
Okay.
Okay, then that's all for today's class. Okay, and sorry I did not give a break to you guys. Okay, okay, we'll meet you in the next class. Okay.